one-step equations. In this lesson, we're going to talk about how to solve one-step equations. So first, what is solving an equation? To solve an is to find the value of a variable or variables that make an equation true. That's it. You're just trying to figure out what value makes the equation true. The value is called the solution to the equation. How do we solve the equation? Well, we use what's called an inverse operation. So that means we undo the operation. So for example, addition and subtraction are inverse operations, right? If you want to get rid of a positive value, you can subtract it from both sides. What lets us do that? Well, these properties of equalities. So I'm going to run through real quick. We're at the reflexive property, A equals A. Symmetric property, if A equals B, then it makes sense that B would also equal A. The transitive property, if A equals B and B equals C, well, since these match, you kind of go from here all the way to here, and A equals C. They're the ones we use to do inverse operations. So for example, the addition property, if A equals B, then you're allowed to add a value to both sides. In this case, C is C. So as long as you add to both sides, you're golden. Same thing with subtraction property. If A equals B, you can subtract the same thing from both sides, and it's still a true equation. You can do the same thing with multiplication. If A equals B, you can multiply by the same number on both sides. And you can do the same thing with division. If A equals B, you can divide both sides as long as the number is not 0. Okay, and there's a substitution property. If A equals B and you know what B is, then you can substitute it in and get the value of A. Anyway, let's solve some problems here. So we're going to solve these one-step equations. So on our first example here, I have x minus 7 equals 12. The general rule here is the equal sign is kind of like a wall. Right? Whatever you do to this side, you have to do to this side. So in this case, we want to get rid of that 7. It's a negative 7. So we want to do the opposite operation. We're going to add 7 on both sides. Because whatever I do to one side, I have to do to the other side. Right? So whatever I do to the left side of the equal sign, I got to do to the right side of the equal sign. On the left side, these cancel out. You just start with x equals 12 plus 7 is 19. And there we go. We do the same thing over here. Right? Here's my equal sign. There's my wall. I have n plus 5. Right? I only want the variable here. So I'm going to get rid of that plus 5. So I'm going to do the opposite operation. We're going to subtract 5. These cancel. I get n equals negative 22. Example 1c. 5 minus n equals negative 1. So here's my wall. It's probably more of a two-step, but we'll take it anyway. Let's get rid of the 5 here. So that's a positive 5. There's no number in front of us. We're going to subtract 5 from both sides. Again, whatever you do on one side, you do the other side. So these would cancel. Negative n equals negative 2 and negative 5. They're both negative, so you just add them, you get negative 7. Right? Anytime they're the same sign, you just add. So I just get more negatives. And then here we're actually not done yet, because I just have negative n. You don't want it at negative n, you just want n. So to get rid of that negative 1, we're going to divide both sides by negative 1. So negative n divided by negative 1 is just n. And negative 7 divided by negative 1 is 7. Right, so again, equal sign is kind of like a wall. Whatever you do to one side, you have to do to the other side. And we want to do opposite operations to get rid of them. So a few more. So in this case, again, there's my little wall. There's the equal sign. I have a negative 4 there. I want to get rid of it. So we're going to, right now it's being multiplied. It's x times negative 4. Let's get rid of it. Do the opposite. We're going to divide both sides by negative 4. These cancel. You get x equals 24 divided by negative 4. Remember, when you divide by negative, it flips the sign. So it becomes a negative 6. The next one, kind of the same thing. Negative 5 times x. So here's my equal sign. Divide by negative 5. X equals negative 5 by that is 15. There you go. 18y equals 54. There's my equal sign. These are being multiplied, so we're going to divide. You get y equals 3. Okay, let me move on to, I think it's the last one. So, same idea here. These are fractions we'll see right now. Right, so there's the equal sign. I have x being divided by 2. So opposite of dividing is multiply. We're going to multiply both sides by 2. Whatever you do to one side, you have to do to the other side. These cancel, you get x equals negative 12 times 2 is negative 24. Next, so I'm actually going to do this one 2 steps. Let's do it in 2 steps. This will show you. And I'll do the one after that in 1 step. So there's my equal sign. What I do this side, I do that side. First, let's get rid of the 3 on the bottom. So since it's being divided by 3, we're going to do the opposite. We're going to multiply by 3. multiply this side by 3, multiply this side by 3. Those will cancel out, and you get 2x equals 18. So we're there now. Again, x is not by itself, so you have to keep on going. So let's divide by 2. Whatever I do to one side, I do the other side, and you get x equals 9. Right, so in this one, it's kind of a similar problem, but instead of just taking it in 2 steps, I'm gonna go a little faster. I'm gonna do it in 1 step. So one way you could get rid of this fraction here is you can multiply by the reciprocal. So instead of multiplying just by 3, we're gonna totally flip it up. So multiply both sides by 3 over 1, and then also the negative, because I get rid of that negative. So I'm gonna multiply this side by the same thing, negative 3 over 1. Now here's the thing, I'm gonna rewrite it so we can see a little nicer. We have negative 3 over 1 times negative 9 equals, now this would cancel out, that would cancel out, x. Now if you're not sure how to multiply this, anytime you have a number by itself, it's automatically over 1. So if you don't see it, it's over 1. And all you do is multiply across. Negative 3 times negative 9 is positive 27. 1 times 1 is 1. So you get x equals 27. So you can leave it like that, or you just write x equals 27. Either way is fine. Okay, last one goes a little fast. So these are the same, they're just uglier. So if I wanted to solve this one, it has decimals, you're like, oh, that sucks. It does. But it doesn't change the way you solve it. Here's your equal sign. And then you're just like, okay, I want to get rid of I want to get the x by itself. Like I want to get rid of this negative 3.7. So we're going to add 3.7 on both sides. And you get x equal. Now the different signs we're actually subtracting. So it would be 1, 7 minus 4 is 2, carry the 1. It would be 1.25. Or you can use a calculator also. This one, same concept, right? It looks ugly, but solve the exact same way. Here's your equal sign, so here's your wall. You want to get the x by itself, so we're going to subtract off the 1/2. Now in this case, we have 3/5 minus 1/2. If you forgot how to do it, you're supposed to do a common denominator. So this quick review. These both go into 10, so I'll multiply this side by 2 over 2. Multiply this side by 5 over 5. And we get 6 over 10 minus 5 over 10. 6 minus 5 is 1. When you add or subtract fractions, they have to be the same denominator to add or subtract them. And you just add or subtract the numerators, the top here. So I get 1 over 10 equals x, right? Because these canceled out. We have x equals. So again, same process, uglier because it's fractions. Same thing I would say here, right? If I was going to solve this, here's my x. There's my equal sign, so there's my wall. You want to get the x by itself, so we're just in, right now it's being divided by 3.1, so you do the opposite. Multiply by 3.1. I do not know what negative 9.5 times 3.1 is. I would have to use my calculator to plug that in. Okay, last thing, just real quickly. What if it's kind of like a word problem? They're telling the area of this rectangle is 72. They want to figure out what x is. Well, I'm doing this because I want you to do a little review. Area of a rectangle is base times height, or length times width. So we have area equals, let's say, base times height. Well, we have the area, 72. We have the base, we'll call 12 the base. And the height is x. So we have our equation here. We know 72 equals 12 times x. So if I wanted to solve this after I set it up, there's your equal sign. I want to get rid of the 12. Divide by 12. And x would equal 6. So there we go. That one over here, same concept, but it is a triangle. So again, I'm just going to partly just sort of help you remind you how to find the area of a triangle. Area of a triangle is basically half of a rectangle. Kind of see it there, right? So it's 1/2 base times height. That sort of formula. They tell me the area is 48, so it'll be 48 equals 1/2 the base, which is 16, times the height, which is x. So we have that. And then here what we're going to do is simplify first. So 1/2 times 16 is 8. So you get 48 equals 8x. And then all we have to do is divide by 8. And x equals 6 again. And there we go, that's the lesson.